Welcome to the basics of network analysis. Now we'll be looking at open and short circuits. What is an open circuit? Is there any significance for an open circuit? Do you want to see a glaring example for an open circuit? Here it is. Yes, a battery lying in a shelf is an open circuit. You can see many open circuits here. They are open circuits. You can see here in terms of symbol. So no current flows when battery lying in shelf are not connected in circuit. No current flows through it. But it is still something, right? It's not that nothing. It has got voltage in it. That's why we use it. And when you measure it, you will know there is a voltage. Maybe you can't feel it here for this battery. And this battery may have some internal resistance, or the wires which you are connecting may have internal resistance, or the circuit external resistance may be there. Everything can be represented here by resistance R. Even then, the terminal voltage will be same as this. That is called open circuited voltage. You have this open voltage at this terminal. Do you want to see more familiar example for an open circuit, which we see every day almost, and also we feel, also you can't think that it is nothing. That is this one. Yes, you can feel for it, right? And we don't dare to put our fingers in that. And actually, if you put after that, you may not even feel anything. Once for all, last feeling. So don't do that. It could be a short circuit. Okay, but we are talking about open circuit at this time. This is an open circuit. Do you really want to know what is the voltage across this? Yes, of course, because we want to connect some device there, so it should match the voltage and the current and other things. Okay, suppose I buy something in US and then I want to connect it here. I will generally buy an adapter, right? You can't directly put in, it may damage or. And not only this, any electronic module has got some input terminals, output terminals, and apart from impedance matching, which we will learn later, the terminal characteristics are also important. So it's very important to know open circuit voltage and the terminal current when you connect some load to this. So it is actually important to estimate this, and it is also easy to calculate open circuited voltage, and it is also useful for applying Thevenin's theorem, which we will learn in network theorems. I would like to thank Bixby for giving this kind of images for copyright free images. Now we have a simple circuit, open circuit as an example here, 15 volts battery, 10 kilo ohm resistance, and open terminals. No current flows through the open circuit, so I equal to 0, current 0. And even in the open circuit, the Kirchhoff's voltage law is applicable. And so if you start from here, the sum of the voltage, algebraic sum of all voltages must be equal to 0. So 15 minus, here actually there is no voltage because I equal to 0, no voltage drop, and minus VCD equal to 0. That's what terminal voltage is. VCD will be 15 volts. Now we'll be seeing some examples, kind of different configurations, and learn how to calculate open circuited voltage. Let's start with this. And here they are open terminals, and we want to know what is the voltage across this. That means whatever is the voltage here, the same voltage will appear here because there is no voltage drop here. Now, since it's an open terminal, so no current flows through it. So actually, these two are in series. Since these two are in series, this is a voltage divider simply. You can find what is the voltage here. Or you can say 6 plus 2 is 8 ohms, 16 by 8, 2 amperes of current is coming here, 2 into 6, 12. Here 4 volt, here 12 volts. The 12 volts will appear at the terminal. That is open circuited voltage, VAB equal to 12 volts. Let's see another example here. This you should try. You can put a current, imaginary, you can imagine current like that, but the value of current will be 0. So 30 minus VAB minus 15 equal to 0. This is minus because I am coming from positive terminal to negative terminal. Now suppose you connect another branch here. This will not affect the voltage here. This will be same. and here you will see 8 volts. You should try yourself and try to understand. And now another configuration, we want to know what is the voltage here. This is actually ground. So VA minus VB is actually VA in this example. So what is VA is the voltage across the 6 ohm resistance is, because there are no other elements on the path, it's easy for you to recognize that the voltage across 6 ohm resistance is the voltage across these two terminals, or this voltage minus this voltage. And so now since this is the open circuit, these two are in series, 6 plus 2, 8, 16 by 8, 2 amperes of current is coming. And so there is a 4 volt drop there, 12 volt drop there. So here it is 16 minus 4, 12, and this is 12. This is a hint I will give you when you are doing problems. Sometimes it's better to do on both sides and compare so that you are not doing any mistake. Both sides it should come 12. Here also 12, here also 12 volts. So now another example here you should try here. This is again, since this is open, this is a series circuit. You can exchange if you want. Otherwise you can 8 minus 16 is 8 volts, and then resistance, and then calculate what is the voltage drop here and subtract here, or what is the voltage here and then see VAB. So both sides it should come same. You should try on this. Now we have another example. We have to find VAB, means first you find VA and VB and subtract. And here it is going from plus 10 volts to ground. So since it is open circuit, I can consider it as series. A current I1 for example is flowing, that will be 1 milliampere, because 2 plus 8 is 10, 10 by 10 is 1 milliampere. And that 1 milliampere will give voltage what? 1 into 8, 8 volts, right? 1 into 8, 8 volts here. No, wrong, because I told you that once you take this terminal here, that means you are measuring voltage from here to ground, not here to here or whatever. Whenever one terminal is hanging, you are measuring voltage, means the reference is ground. So from here to here, that means voltage across 2 kilo ohm resistance. So 1 into 2 is 2 volt is here. So generally common mistake people do, that's why I'm telling you. And here it is again 10, so 1 milliampere and 6 volts, and VAB is minus 4 volts. And the same circuit, similar circuit, I'm showing in a different configuration here. Numbers are different, but it is same. You should realize that this previous circuit and this circuit are same, except that here numbers are different, two different voltage sources are there. But you see, there is an open circuit, no current flow. So these two are series. This 30 volt divides equally. So you have 15 volts as VA, and 20 volts will divide here. You have 10 volts here. 15 minus 10, 5 volt is the VAB. Now let's see what is a short circuit. When people say short circuits, immediately that comes to our mind is the accidents, fire accidents that happen, short circuited. Some building is burned because of short circuit. This kind of things. What is a short circuit? Generally, people generally refer short circuit to the direct short of the source. That means you take a wire and put it in plug, it will burn. You should not do that. I'm just telling as an example. Now here, if I take this battery and just short it, then all the current will flow through this. Resistance is 0, 0 into anything by 0 plus anything is 0. So the entire resistance is 0. You will have kind of infinite current. And so this will melt and burn, and then something can happen. This is short circuit. This is what people refer to generally short circuit, and you should not do this. We should be always careful, particularly when you are using diodes and all. That's why we recommend always to have a resistance always in series, because a diode, which you will learn later, when it is conducting, it becomes almost like a short circuit. So whenever you're connecting a diode, you remember to keep a resistance at least to limit the current. Okay, what happens here if you connect it like that? That happens. And you will have a Diwali, festival of crackers, and circuit burns. It is not safe. We are not concerned about, we don't want to do this and not concerned about this kind of short circuit. But what I mean to say is we were talking about shorts within the circuit and some other places like here. Here there is a short, you see. Now I want to know what is the voltage across this. Of course, I have written here. It is 0 because resistance is 0. It is 0. Now, what is the current flowing through this? Here you should know that once you have short circuited, generally you need not see what is there on the other side, because if you calculate R1, R2 by R1 plus R2, R1 is 0. Mathematically, it is 0 resistance. And otherwise also, once you short circuited, current finds lowest path, lowest resistance path here. So all the current will be flowing here. No current will flow here. So this resistance is actually effectively not there. It is like you have actually opened it. So now you have only 16 volt and 2 kilo ohm resistance. So 8 milliampere current is flowing there. This is exactly like this here. There is a water tank here. If this valve is closed, water will be going like that to the, if I say this is output, water will be flowing that. Once you open this, it's like short circuited. All the water will flow here, and you may not get water here. And this is also a kind of NOT gate or inverter, which we'll see in digital electronics, because if you open this valve, output will be 0. And if you close this valve, you will have some output here. So this here I have put, actually you can even put the short circuit means you should put a hole in the tank. The entire water will directly go. No need to do any calculation. A hole in a tank. So these shorts you should try to analyze. Open circuits and short circuit we should analyze, which is useful for further analysis for applying Thevenin's and Norton theorems and other places. Now I have another example here. You see there is a short here. So if there is a short here, then you should not worry about what is there on the right side, because now these two are in parallel with this, so it is 0. That's what I have been explaining. Now you have 6 parallel, 3 plus 2, 5, 10 by 5 is 2 milliampere will come and divide equally here 1 and here 1. You should calculate yourself. Of course, if there is a source on this side, then we can't simply ignore it. Then you have to calculate current due to both the sources. So you can apply superposition theorem or some other theorems, some other techniques, which I will teach there later. But right now I am telling you to ignore the right side if there is no other sources on this side. Okay. Now there's another example. Suppose I shifted the short here, then the entire circuit on the right side doesn't matter to me now. Only 10 by 2. 5 is a short circuit. So you should learn calculating short circuited current or open circuited voltage. Once again, if open circuit is there, current is 0, but you should try to learn calculating open circuited voltage. And when you have a short circuit, current is voltage is 0, but you should try to calculate or learn calculating short circuited current. Okay, so you practice problems from these books. Thank you very much.